solution है। क्यों? x is equal to b minus a which is an integer. So equation of the type x plus a equal to b is solvable in the set I, right? But you see, now the equation of the form x a is equal to b, where of course a is non-zero, x a is equal to b. Now this equation is this time not solvable in the set of integers. As you know, in this case x value of x will come out to be b upon a, which is, and this value is, you know, not a integer. So now this time this set of integer is extended to set q. Set q is set of rational number. It means now this equation has a solution in the set of rational numbers. Now next, now comes to equations of the type x square equal to 2 or x square equal to 3 and many of similar types. Now these equations are not solvable in Q. It means ਇਹਨਾਂ ਇਕੁਏਸ਼ਨਾਂ ਦੀ ਨੂੰ ਆਪਾਂ ਸੈਟ ਆਫ ਰੈਸ਼ਨਲ ਨੰਬਰਸ ਦੇ ਵਿੱਚ ਰਹਿੰਦੇ ਹੋਏ x ਦੀ ਵੈਲਿਊ ਨਹੀਂ ਲੱਭ ਸਕਦੇ। ਸੋ ਹੁਣ ਆਪਾਂ ਕੀ ਕਰਦੇ ਹਾਂ, ਸੈਟ ਆਫ ਰੈਸ਼ਨਲ ਨੰਬਰਸ ਨੂੰ ਫਰਦਰ ਐਕਸਟੈਂਡ ਕਰ ਦਿੰਦੇ ਹਾਂ ਟੂ ਐਨ ਲਾਰਜਰ ਸੈਟ ਵਿਚ ਇਜ਼ ਆਰ ਸੈਟ ਆਫ real number. Set of real number include both rational and irrational number. So these equations are solvable in set of rational numbers. Now take another equations, say x square plus 1 equal to 0, x square plus 4 equal to 0. Now these equations are not solvable in R. R means set of real numbers. As we know that in the set of real number there is no real number which is negative of, there is no real number whose square is negative real number. So these equations are not solvable in the set of real numbers. Here Euler was the first mathematician who introduced the symbol I, which is actually iota, for the square root of -1. It means Euler was the first mathematician who introduced iota as a square root of -1, as a square root of -1. Now this helps in exploring the concept of complex numbers. Here iota is square root of -1, it means iota square is -1. ਇੱਥੋਂ ਆਪਣੇ ਕੋਲ complex numbers ਨੂੰ ਅੱਗੇ explore ਕਰਨ ਦੀ help ਮਿਲੀ ਹੈ। Now ਹੁਣ iota square is -1, ਇੱਥੋਂ ਆਪਾਂ iota ਦੀਆਂ higher power ਵੀ solve ਕਰ ਸਕਦੇ ਹਾਂ, integral powers of iota. How? Take iota raised to power say 135. ਇਹਨੂੰ ਇਸ ਤਰ੍ਹਾਂ ਆਪਾਂ ਲਿਖ ਸਕਦੇ ਹਾਂ iota square ਦੀ power 67 into iota. Clear? Now iota square is -1, so -1 raised to power 67, which is an odd number, it will comes out to be -1, so it is minus iota. Now similarly iota raised to power 21, iota ਇਸ ਨੂੰ ਲਿਖ ਸਕਦੇ ਹਾਂ ਆਪਾਂ iota square raised to power 10 into iota. Now iota square means it is simply -1 raised to power 10, which is 1. So 1 into iota, it is simply iota. Now next is imaginary numbers. The square root of a negative real number is called imaginary numbers. The square root of a negative real numbers is called imaginary number. Now we first define what is complex number. If you take A and B, A and B two real numbers, then number which can be put in the form A plus iota B is called complex number, where both A is real, B is real. So, number which can be put in this form A plus iota B is called complex number. A is called real part and denoted by REZ. It means real part of Z, and B is called imaginary number and denoted by this imaginary part of Z, IM brackets Z. Now, next is let Z is equal to A plus iota B be any complex number Now, if A is equal to 0, then Z is called purely imaginary number. And if B is equal to 0, then Z is purely real number. Now, equality of two complex numbers. Equality of two complex numbers. Let Z1 is equal to x1 plus iota y1 and Z2 is equal to x2 plus iota y2 be two any non-zero two complex numbers. Now, Z1 is equal to Z2 if and only if x1 is equal to x2, y1 is equal to y2. It means when two complex numbers are equal, their corresponding real parts are equal and corresponding imaginary parts are equal. So, we say two complex numbers are said to be equal only if their corresponding real parts are equal and imaginary parts are equal, and vice versa. If any two complex numbers having same real part and imaginary part, then both the complex numbers are said to be equal. Now, addition of a complex number. First, we solve a problem using equality of two complex number. If Z1 is equal to 2 minus iota y and Z2 is equal to x plus 3 iota, then find the value of x and y. Find x and y given is z1 is equal to z2, means these two complex numbers are equal. Now since z1 is equal to z2, therefore both the complex numbers for equating the real and imaginary parts as the both complex numbers are equal, so their corresponding real parts are equal. So 2 is equal to x and minus y is equal to 3. This implies y equal to minus 3. Now next is how to add two complex numbers. Addition of complex numbers. Take z1 as first complex number x1 plus iota y1 and another non-zero complex number x2 plus iota y2. So addition of a two complex number is also an complex number. It means z1 plus z2 is also a complex number. Addition किमें करनी है? Simply real part ਨੂੰ real part से add करो और imaginary part ਨੂੰ imaginary part से add करो. दोनों दे real part से add करो और imaginary part से add करो. So addition of a complex number is again a complex number. Clear? So real part of addition is equal to the real part of, if you real part of z1 plus z2 is actually real part of z1 plus real part of z2. Similarly, imaginary part of z1 plus z2 is imaginary part of z1 plus imaginary part of z2. Clear? Now, multiplication of two complex number. Now, multiplication is simple. If we take same complex number z1 and z2, so it is simply x1 plus iota y1 multiply x2 plus iota y2. So it will comes out to be x1 x2 plus iota x1 y2 plus iota y1 x2 minus iota square is minus 1 y1 y2. So it is x1 x2 minus y1 y2 plus iota x1 y2 plus y1 x2. So multiplication of a complex number is again a complex number. Now multiplicative inverse. Now every non-zero complex number for every non-zero complex number say z, there exists another complex number say z1 such that Z into Z1 is equal to 1 is equal to Z1 into Z, and Z1 is called multiplicative inverse of Z and denoted by as Z1 inverse. Z1 inverse. So, Z1 is called multiplicative inverse of Z if Z into Z1 equal to 1, and also Z1 into Z is also equal to 1. So, Z1 is called multiplicative inverse of Z. Now, division of complex number. Now, division of a complex number Z1 number Z1 by a non-zero complex number Z2 is defined as division of a complex number, say Z1, by non-zero complex number Z2 is defined as multiplication of Z1 with multiplicative inverse of Z2. So, division of a two complex number Z1 and Z2 is actually multiplication of Z1 with multiplicative inverse of Z2. So, division of Z1 with non-zero complex number Z2 is actually, it is multiplication of Z1 with multiplicative inverse of Z2, that is Z1 into Z2 inverse, and this division is again denoted by Z1 upon Z2. So, Z1 upon Z2 is actually Z1 multiplication of Z1 and multiplicative inverse of Z2. Now, next is conjugate of a complex number. Consider a complex number x plus iota y, then conjugate of z is denoted by z bar is actually z bar is equal to x minus iota y, x minus iota y. You simply change the sign of imaginary number. Conjugate find out करने वाले आप की करना है, simply imaginary number दा sign change कर देना है. If we have complex number of the type say 3 minus 4 iota, so z conjugate की आएगा 3 plus 4 iota. जे अपने को complex number है -1 plus iota, ता z conjugate की आएगा -1 minus iota. Real part the sign नहीं change करना, imaginary part the sign change करना. Now next is how to find the square root of a complex number. सारे complex numbers ਦਾ square root ਆਪਾਂ ਇਸੇ method ਨਾਲ find out ਕਰ ਸਕਦੇ ਹਾਂ. So consider a complex number z is equal to 5 plus 12 iota. ਹੁਣ ਇਸ complex number ਦਾ square root find out ਕਰਨਾ ਹੈ. Let x plus iota y be the square root of this complex number. Suppose ਕਰ ਲੈਂਦੇ ਆ कि x plus iota y is complex number ਦਾ square root है. Now squaring both side, x plus iota y is equal to x plus y iota y is square root of 5 plus 12 iota, sorry. Now x plus iota y square is equal to 5 plus 12 iota. Now this is x square minus y square, as iota square is minus 1, so x square minus y square plus 2x y iota is equal to 5 plus 12 iota. Now using the equality of complex numbers, two complex numbers are equal if their corresponding real parts are equal and imaginary parts are equal. So using equality of two complex number, x square minus y square is equal to 5 and 2xy is equal to 12, right? Now using this identity, x square plus y square whole square is equal to x square minus y square whole square plus 4x square y square. Now substitute the value of x square minus y square, which is 5, so it is 25, and value of 4x square y square, as 2xy is 12, so 4x square y square is 144. So it implies x square plus y square is equal to this is 169, so this is 13. Now we have one equation, x square minus y square is equal to 5. Second equation, 2xy is equal to 12, second equation, and third equation is x square plus y square is equal to 13. Now using 1 and 3, we get x square is equal to 9 and x is equal to plus minus 3, and y square is equal to 4 and y is equal to plus minus 2. As you see, 2xy is equal to 12. Product of xy is 12, which is greater than 0. It means xy is greater than 0. It means x and y should have same size. x और y ਦਾ ਜਿਹੜਾ ਸਾਈਨ ਹੈ ਉਹ ਸੇਮ ਹੋਣਾ ਚਾਹੀਦਾ ਹੈ. ਸੋ ਆਪਣੇ ਕੋਲ ਵੈਲਿਊਜ਼ ਜਿਹੜੀਆਂ x ਔਰ y ਦੀਆਂ ਆਣਗੀਆਂ, either x equal to 3 and y equal to 3, or x equal to minus 3, sorry, y equal to 2, x equal to minus 3 and y equal to minus 2, क्योंकि x y the product positive है, so दोनों x y ਦੇ ਜਿਹੜੇ साइन है वो same होने चाहिए. Now next is modulus and amplitude of complex number. Modulus and amplitude of complex numbers. Let z is equal to x plus iota y be any complex number. Now, the plane where we represent this complex number is called complex plane or Argand plane. Complex number geometrically is called complex plane or Argand plane. Now, let the point in the complex plane is Pxy, center is O, this is your x axis, this is your y axis, and draw a perpendicular from P on the positive direction of x axis. Now, the x axis is actually real axis, act as a real axis, and y act as a imaginary axis. The length of the line segment OP which is now this length of line segment OP is called modulus of z, which is this complex number, and the angle theta which the line segment OP makes with the positive direction of x axis with anti-clockwise sense is called argument or amplitude of the z, and theta angle which the line segment OP makes with the positive direction of x axis in anti-clockwise sense is called argument, which is ARGZ, or amplitude of z, amplitude of complex number z denoted as AMPZ. Here is your so this theta is actually your amplitude. Now, and this length of line segment OP is your modulus z, and this angle theta is amplitude or argument of z. Now, how to find the argument or this theta amplitude of z is, now in this triangle POM, tangent theta is PM upon OM, and you know PM is y, OM is x. So, tangent theta is